right. Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right back on into it because we're going to do the second half of this worksheet. We did the first half last week, and then we're doing this half this week. Because it's systems, it takes a long time to do, so I wanted to chop it up so the video wouldn't be insanely long. We have it chopped up. So I'm going to do the second half. If you missed the first half, if you want to see the first few that are on the first page, then that's going to be a separate video. I'll have that link in the description. If I forget, let me know. But it should be there, so you'll be able to click on it, or you can click on the little thing at the end of the video and do it that way as well. So we're going to scroll all the way to number 13 and dive back on in at 13. Okay, so at this point in the game, we're past the point where they're already lined up and they're already opposites, so it's already set up perfectly. And we're past the point where they're just maybe they're the same. So like the numbers in front of the X or the Y are the same, but they also have the same sign. So we want one of them to be the opposite, so we just kind of switch the signs. That's also pretty nice. Or if you can kind of just multiply one of the equations by something, and then you get opposites, that's kind of nice too. Now we're at the point where none of that is happening, all right? We're at the point where none of that is happening, and we have to either multiply both equations by something in order to get the X or the Y stuff to cancel, or we have to divide. Dividing is easier than multiplying if everything divides by something, because it makes the numbers smaller, right? Unless you're, dividing a fraction, I guess. But, in the context of what we're doing here, dividing is going to be better. So, for instance, if I take all of this stuff, all of that stuff divides by 2. So that's going to make this equation smaller and more manageable, right? And then that equals 5. And then this equation also, everything divides by 2. Right? So I'm actually going to write this one right below it because I don't know yet. Oh, actually, you know what? Hold on. Let's not. So we can divide it by 2. Actually, we will do it, but we will. I just noticed that the 8x and the 8x here now cancel, but we can divide it by 2 anyways. So it'll make it nicer for when we need to plug it back in. So I still want to divide everything by 2. However, I just noticed 8x in the first equation after I divide by 2, and then negative 8x in the second equation before I divide by 2. There we go. We got it to work. So you kind of just have to play around with it a little bit. So I was going to just divide both of them by 2 and just kind of see what happened from there, but then I noticed that I have opposites. You just want to do whatever you got to do in order to make opposites. Once either the X numbers are opposite or the Y numbers are opposite, then you're ready to go on to the next step, which is to line them up and add or subtract, or however you want to think about that. Be careful if you're going to subtract them, by the way, because if you're subtracting the second row, then technically it's like all of that stuff is the opposite sign of what it was, so you have to be really careful with that. So that's why sometimes this is called addition elimination, because you're adding the 2 equations typically. So slash 8x minus 8x is 0, minus 5y minus 6y minus 11y. 5 plus 6 is 11. Divide both sides by negative 11, you get negative 1. There we go. All right, awesome. By the way, if you're watching this and you haven't seen the first half, but you figure you'll just, continue watching the second half and you're a little lost right now, that's because I am going a little bit faster on purpose. I went slower in the video where I was doing the first half because we were just starting out. I'm going a little bit faster in the second half because I've already had that time to kind of build up to the speed that I'm going at now. So if it feels like I'm going a little fast, go back to that other video where I'm doing the first half of them. I go slower in that one, especially at the start. And if you feel like I'm not going fast enough, then stay tuned because I will start to go through them faster and faster as we go here. If you want to scrub ahead a little bit and get to expert mode, you can, or just play it at double speed. I don't know. Well, you do you. But I'm going to plug in my y value now. Minus 3. And then plug in a negative 1. So that's going to be negative 4x. And that's a minus, by the way. It's a bad minus. Minus 3, minus 1, so plus 3. Oh, I'm going to subtract 3 on both sides and get 0, which means x is 0 because I'm going to divide by negative 4 and get 0. Look at that. All right, so x is 0, y is negative 1. Moving on. So again, remember, if you can divide, then divide. I'm going to divide this right here by 2. Divide by 2. So what happens when I divide by 2? Let's find out. 8 divided by 2 is 4. 14 divided by 2 is 7. 4 divided by 2 is 2. And looky there, that is going to work. Boom, boom, boom. Slash, slash. 4 minus 6 is negative 2. 2 minus 10 is negative 8. Divide both sides by negative 2. And there we go. All right. So then I want to plug in and get my y, so I can just kind of plug in right here. I've got the space for it. So I'll just do it right here. Negative 6. Plug in my x. Negative 10. It's going to be negative 24. And then I add 24 to both sides. If I'm adding 24 to a negative 10, that's actually the same thing as if I say 24 minus 10. So negative 10 plus 24 is literally the same thing as 24 minus 10, which is 14. And then if I divide by a negative 7, I get negative 2. Bada bing, bada boom. So there we go. All right, next set. I believe that's a 15. That's a 5. Looks like this time I'm not going to be able to get around the whole, like, dividing to be able to solve my issues. However, if that's 15, which I think it is, I can times this by 3 and get 15, or I can times this by 4, negative 4. Over here, if I take the x, if I want the x, I divide or times the second equation by negative 4. If I want to get rid of the y, I would just times the second equation by 3. Timesing by 3 is going to be easier than timesing by negative 4. So I want to times by 3. All right, so I'm going to copy the first equation. I don't need to alter the first equation. Negative 4x minus 15y equals negative 17. I'm going to times everything by 3 in the second equation. Negative 3x plus 15y equals 3 times 13 is negative 39. And there we go. There it is. It cancels. All right, so that's what we're trying to do. We're trying to cancel something. You can cancel x or y. I could have canceled x, and it would eventually, get to the same exact answers for x and y. But doing it where I cancel the y out first was easier because it's a smaller number, and I don't have to multiply by a negative that way. All right, so choose the lesser of two evils. Choose the one that's less math and easier for you to do. All right. You don't got to prove anything to anybody other than getting the right answer. Okay, so I'm going to add these up. These are both negative, so they're both they're going to get added. All right, that's going to be 3, 4, 5, 56. Divide by negative 7. I don't know why I showed that step. I normally don't show that step at this point in the game, but I did, so whatever. All right, x is 8, so I'm going to plug that in. Negative 8, 5y. Negative 13. So I'm going to add 8 to both sides. So that's going to be the opposite of 13 minus 8, so which is negative 5. So y is equal to negative 1. All right. Over here, it looks like I could times by a negative 2 or a negative 4. I'd rather times by a negative 2. If I times by a negative 4, I would get the x's to cancel. If I times by a negative 2, I get the y's to cancel. All right, I'm just choosing the lesser of two evils here. 2 is smaller than 4. All right, so that's going to be a 2x plus 14y equals negative 28. And then I have negative 4x minus 14y equals 28. When I go to add these, I'm going to get a negative 2x. That's going to cancel. That's going to cancel also. Be careful when you cancel one side of an equation completely. It does not turn it into an expression. Do not make that mistake. An equation will never magically turn into an expression. That doesn't happen. When you solve an equation, it's kind of like it turns into an expression, because then you say the answer, like if x equals 2, then 2 is the answer. 2 is an expression. So once you solve an equation, you can kind of sort of get rid of it in a way. But as you're solving an equation, you're not going to all of a sudden turn it into an expression. I've seen people do that. It's not the right move. It always gives you the wrong answer. All right, so don't do that. It's still an equation. It's just that we canceled everything out on the right-hand side, which means there's a 0 there. There would be a 0 right here as well. Negative 2x plus 0 equals 0. I don't need to put plus 0 on the left-hand side, though, if there's already something there. But since there's nothing there on the right-hand side, I have to put something there as a placeholder. So 1 is the most common placeholder. It's like a ninja. But 0, every now and then, is sometimes a placeholder as well. So it's kind of a ninja, right? It's kind of a ninja, like Naruto at the very beginning of the first Naruto show, right? Before he becomes good at things and stuff, right? And then 1s are like Naruto at the end of Shippuden. Okay, so let's plug that x back in. So that's going to be, I'm going to plug that into the first equation. The first equation has smaller numbers, so I like that better. So negative 0 minus 7y, 14. So that's just 0, right? So that's just this. And then divide by negative 7. Boom. There it is. Okie dokie. 17 and 18 are up next. I'm going to switch colors because I feel like it. And let's see. Okay, so this one is actually pretty gnarly. Nah, I definitely switched colors at a good time here, because if you look at 17, none of my previous tricks really help me here. I can't divide the first or the second equation because there's no common factors. If I divide it by something, I'd have fractions somewhere, and I don't want fractions. I can't just switch the signs. I can't just multiply one of the equations by something to get the other. None of those options work. So now we're at the worst of the worst. Well, it can always get worse, but the worst so far, right? Like, you know, if you're having the worst day of your life, let me just remind you that it's the worst day of your life so far, right? It can always get worse. So, and hopefully you're not having the worst day of your life. I you know, genuinely, I really hope that you're not having the worst day of your life. That would be terrible, especially if you lived a long time, because then you've had a lot of days to build up to that day. So it's probably a pretty bad day, but hopefully not. Hopefully you're having a good day today. Let me know how your day's going if you want. So anyways, what I want to do here is I want to say, okay, well, which numbers, like, collectively are smaller? Well, 8 and 9 versus 7 and 4. 7 and 4, you can add them up maybe if you want some sort of objective way to look at it, but 7 and 4 are smaller than 8 and 9, right? So because those are smaller, I want to try to eliminate the x's. Okay, so I'm going to actually have to times both equations now. And this method, what I'm about to do here, is actually the method that works on all of the previous ones I did. It's not the fastest way to do all the previous ones that I did. If it was, I would have done that. But this method I'm about to do here will work on every system of equation problem as long as you already have it lined up. Right? So that's the part where this could get worse, is if they aren't already lined up and you have to do elimination method. If they're not already lined up and you have to do elimination method, you got to line them up. They need to be aligned. If they are already lined up, like they are here, and you can't do any of the other little tricks I did before getting to this point, here's what you can do, and this works on every system of elimination problem. You times them by the leading coefficient of the other. Basically, the first number you see times the other equation by that. All right, so I'm going to times this by negative 7, and I'm going to times this by negative 4. Okay, that's step 1. Step 2 is really small in comparison. biggest step is step 1, but there's a tiny little tweak that we need to implement here. Okay, I need to change the sign of one of these numbers, because if I do what I have right here, I'm gonna have the same exact coefficient for x, and they're not gonna cancel if I'm adding the equations. Now, if you're subtracting them, then yeah. So if you're gonna do subtraction, yeah, awesome. Just be careful though, because you have to distribute that negative on the bottom row. So you'd actually be adding 22, and you'd actually be subtracting a 9. Okay, so just be careful there. What I'd rather do is just change the sign of one of them so that they're just opposites already. Okay, so just make that one a positive. Okay, so basically multiply them by the first number you see. Multiply the other equation by the first number you see. Okay, so once you do that, you just kind of, do some math. So 4 times 7 is going to be 28. So that's positive 28x. And then that's going to be a plus 32y. And then that's equal to negative 36. All right, second equation, that's going to be a negative 28x. That's going to be 7 times 9 is 63, so plus 63y. And then 7 times 22, I don't have that one memorized. Let's see, 14, 7, 154. Should be 154. I might have did that wrong, so, let me know if I did that wrong. I'll get a weird number if I do, because all of the previous answers have been integers, so I'm expecting my answers to be integers. So I'll probably just be able to check my work by just trusting that I should be getting integers for answers here. So that's going to be 95y, and that looks like that's going to add up pretty nicely. What is that? That's a 0, 3589. Oh, and that's negative. That looks like that's going to go in evenly. Maybe? Maybe go in evenly. Let's find out. Because it's 95, 2 95s would, is that a 190? Yeah, because 90 and 90 is 180. So yeah, that would be 190. So that's going to be negative 2. Okay, some big numbers there. I kind of second guessed myself on that one. So when we're plugging it back in, it's not a huge deal which equation you pick. However, choose the lesser of two evils. Work smarter, not harder. I'm all about working smarter, not harder. So the first equation has smaller numbers than the second equation, generally speaking here. So we're going to choose the first equation when we plug our stuff back in. So negative 7x. I didn't solve for x, I solved for y. So negative 7x minus 8. I did solve for y, it was negative 2 equals 9. All right, and then I do some math. 8 times 2 is 16. I'm going to subtract 16 on both sides. Divide both sides by negative 7. Ooh, almost put a negative. That's going to be a positive 1. And there we go. All right, looks like I did have that right. Okay, cool. Whew. And that's about as hard as it gets. I mean, it can always get worse. And then after that, you can make it worse. But practically, like out of all the systems problems I've ever seen, especially in Algebra 1, because it's technically an Algebra 1 worksheet, that's about as tough as it gets. That's about as tough as it gets. Okay, so moving on. We're going to have to do it again for number 18. 5 and 3 are smaller than 4 and 9. So we're going to times them by the leading coefficient of the other. So times that by 3, times that by 5. Okay, I need to change the sign of one of those. Maybe this one. Just make the bottom one negative, I guess. Just for simplicity, always make the bottom one the opposite sign. All right, so let's do some math. 3 times 5 is 15. 3 times 4 is 12. 3 times 3 is 9. 5 times 3 is 15. 5 times 9 is 45. 5 times 18, half of 18 is 9, 90, positive 90. Oh, look, I get two things to cancel. Cool. So then it doesn't even matter what that is, because y is going to equal 0. Because it's going to be blah, 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 y, and blah, blah, blah. Yeah, all that. Okay. Oh, you know what I just realized? I could have divided the second equation by 3. I didn't even think to look because I was just like expecting it to happen again. So I didn't even think to look, but I can divide this by 3. Let me go ahead and do that now. Could have made my life a little easier maybe. I don't know. It's already solved for y, so it's all good. I'm just going to divide by 3 now though. Let's do that. So it's going to be x minus 3y. Go ahead and plug in y, why not? 18 divided by 3 is 6. All right, so that's just going to be 0, so x is equal to negative 6. There we go. Cool beans. All right, next set. That was a terrible slash. Okay. Ooh, I can divide that by 2. Let's do it. Let's do it. So that's going to be, actually, there's more negatives than positives, so let's divide by negative 2. So that's going to be 2x plus y equals negative 7. Okie dokie. This one here, actually, you know what? Let's also do this. Let's take this and let's times it by 7, by negative 7. Yeah, or actually, you know what? Even better, times it by 5. Let's times it by 5, because then I'll get a positive 10x. There we go, that's a smaller number. Okay, so 10x, 5y, negative 35. So the way I do these, the way I'm showing you how to do this, is not the simple method. The simple method is what I did for 17, okay? That's the simple method, just times them by each other and call it a day. If you're using a calculator, the simple method might be the best method for you. If you're able to use a calculator, because then you could just make the calculator do all the individual calculations for you. If you're not using a calculator, then doing what I'm doing is helpful. I'm trying to do the fastest method. Typically, I always try to choose the fastest method, right? Work smarter, not harder. 5 and 7 make 12. Negative 35, negative 25. I'm adding 2 negatives up, so that's going to be negative 60. Y is equal to negative 5. Okay. Then I'm going to plug it in. I kind of want to plug it into the first equation after I divided by negative 2 because I like that equation. 2x plus y, so plus negative 5, is equal to negative 7. So I'm going to add negative 5 to both sides. So that's going to be negative 2. X is equal to negative 1. There we go. All right, over here, let's see. Ooh, I can divide by 5. Let's do that. Divide by 5. So then that's going to be, let's write it below this time. Minus y equal to 2. And then I can times it by 2. So I'm going to just paste this one over. 3x minus 2y equals 2. And then just times it by negative 2. Yeah, we'll just times it by negative 2. So times it by negative 2, it's going to be negative 2x plus 2y equals negative 4. There we go. Now we can get the y's cancel. 3 minus 2 is 1. Ooh, that worked out nicely. 2 minus 4 is negative 2. X is negative 2. All right, then I just plug it in here. This is my nice formula. Small coefficients, small numbers being multiplied by the letters, right? So x is negative 2 minus y equals 2. Add 2 to both sides. And there we go. We got x and y. Okay. We've only got 4 more. We're in the home stretch here, y'all. Let's change colors, because why not? Okay. Looks like we can divide by 3. So let's do that. Let's divide by 3. Divide by 3. So then that's going to be x plus 2y equals 3. Or, sorry, equals 2. Tried to control Z that, and it does not work. There we go. And then I can times that by, let's see, negative 2. Yeah, and then my y's will cancel. All right, so 5x plus 4y, negative 14. Negative 2x minus 4y equals negative 4. Slash. 5 minus 2 is 3. Negative 14 and negative 4, so I'm adding up the 2 negatives. It's going to be negative 18. X is equal to negative 6. Here we go. And then we plug it in. Plus 2y equals 2. Add 6 to both sides. And then divide by 2. There we go. Looks like both of these divide by stuff. That's kind of nice. Let's do it. Divide by 2. And divide by a -5 just because I don't like the negatives. Well, no, let's keep it positive because I want them to be opposites, and it looks like the x's are going to cancel. After I divide by 2 and 5, the x's will cancel. If I keep the signs the opposite of what they are, that is. So let's do that. So divide by 2, so 2 over 2 is 1, so that's x. 8 over 2 is 4. 6 over 2 is 3. 5 and 5 is 1. 20 divided by 5 is 4. Ooh. And then this is going to be -3. Oh, wow. Look at this. Everything cancels. Slash, slash, slash. What does that mean? What the heck? All right, if you've never seen this before, don't freak out. It's actually nice that this happened. Practically, it's really nice that this happened. Your brain might want to like try to die on you if you've never seen this before. But this is nice because we're actually done. We've solved it. It's solved. When you get 0 equals 0, right? Everything cancels. I'm not talking about the x and the y only. Everything canceled. I get 0 equals 0, right? Does 0 equal 0? Does any number equal itself? Yes. Right, I could even say 1 equals 1. Like if I add 1 to both sides, 1 equals 1. Okay? So it could be any number. It doesn't matter, but typically it's 0 equals 0. Any number equal to itself is always true. Always true. Huh. I got the x's to cancel and the y's to cancel. So no matter what I plug in for x or y, both of them cancel, and then I get something that's always true. So what that means is when everything cancels and you get a number equal to itself, the answer is all solutions. All, typically you write it like this. You write it as all real solutions. Right? So in print, all, oh, I almost wrote that in cursive. I forgot how to write a print R for a second. There we go. All real solutions. You can also say all real numbers. So you can say ARS, all real solutions, or you can say ARN, where N stands for number. So you can abbreviate maybe, just, if you're not sure, just look back at your notes or ask the teacher next time you see him or her and just be like, hey, like, what do you want me to put for this? I saw this random YouTuber and they said to call it all real solutions or ARS or ARN, R's or ARN, R's not, and ARN too. Yes, all of those should be fine. But if you have a really picky teacher, they might want you to spell it out and put all real solutions or all real numbers and write it all out. So there's a little bit of nuance here, but basically the answer is that everything is the answer. Oh, there is a more specific way to say this answer. If you define y as like f of x, then yeah, what you could do if you wanted to get really, really technical here, one thing you could do is you take one of the equations, so let's say the top equation, and we solve it for y, and then we divide by 4. Okay, so that's the y value. So then you could basically say that x comma -1/4 x plus 3/4 is the answer. So the answer, this is like a super, super technical way to say the answer. So I don't know if your teacher's looking for that or not, but you could say it like that. And that would be like super, super technical. I don't think they would need you to go that far, especially for Algebra 1. But that might be one of the most. There's, I mean, like I said, it always gets worse. You can always make it worse, right? So there's probably a more technical way to say that. If I tried to say it even more technical than this, I think I might like make a mistake somewhere though, because I don't even know for sure exactly how to do it more technical. I have an idea, but I would just be throwing you off because I don't think you would need to go any further than this. I really don't. Let me know if I'm wrong, if your teacher wants you to say it some other way and I didn't list the type of way that your teacher wants you to list the answer. If I'm missing something here, let me know, but I think that's all the ways that your teacher might want to know the answer. Okay? I think we covered all our bases here. By the way, so the answer was all real numbers, all real solutions, blah, blah, blah. If the x's and the y's cancel, but the number doesn't, so it's like 0 equals 5, or 0 equals 4, 0 equals something other than 0, the answer would be the exact opposite of all solutions. It'd be none. No solutions, no real numbers, no real solutions, no answer, 0 with a slash through it. Any one of those should be fine. Keyword should be. Keyword should. So yeah, if it all cancels out except for the number, so you end up with an equation that's just not true, then there's no answer. Versus here, you get a number equal to itself, so the answer is that everything is the answer, basically. Okay, very, very tricky, so I'm glad there was at least one of those. I don't know about these last two. I haven't worked them out yet. I'm working them out for the first time with you guys here, so let's round this off here. By the way, if this is helpful, of course, you know, like and all that kind of stuff, subscribe, blah, blah, blah. But also just let me know how I can help you. All right, so I have some ideas. I have some things that I want to do and try, see how I can be, you know, more helpful, more effective. I thought about doing like a live thing where I just have like a certain, you know, hour of the day that I block out just for you guys and go live, and just whoever jumps in, you know, I can just help you with whatever homework you're on. But if nobody jumps in, I'll just work on something that I've like already prepared to do, like a lesson on something, and then that way, just after I'm done with that hour, I just post that. So if you think that would be helpful, let me know. Or if you and I have never done tutoring before, if you're seeing me for the first time, or if we've never done tutoring, I always do the first session for free, first hour session, any math subject between Algebra 1, Calc 3. So I'll have my email and all the descriptions below. Anything that can be helpful. I've got some stuff on my website. Go check out my website, myersmathematics.com. One of the first things that you'll see on there is a guide called the 5 math mistakes everyone makes and how to avoid them. Just a little PDF. So hopefully that's helpful. You can grab that. That's for free. You know, go check that out and let me know if that's helpful for you. I've got lots of things. But you know, if you give me feedback, I'll know what else to do and what else might be helpful to show you. So, okay. Actually, you know what? On this last couple, I noticed that we are not all lined up. This is the first time that we're not all lined up. So I'm actually going to switch colors because I think it's worth noting that we are not all lined up here. So that's an issue. Now, they don't have to be the X and then the Y and then the equals and then the number. It doesn't have to be exactly like that, but they do have to be lined up. You want to have all your ducks in a row, right, so to speak. So we just need to get them so that they're in the same order. Well, if I use the first equation as my baseline, and I try to match the second to the first. You can try to match the second to the first or the first to the second. It doesn't matter, but you need to pick one, right? So if I'm going to try to match the second equation to the first equation, then I want to have the number on the left, and I want to have the y and then the x on the right, right? So do I already have that? Almost. I've already got the number on the left of the equals, and I've already got the x on the right of the equals. I just don't have my y in the correct place. So all I need to do is minus 10y on both sides, and then I'll have them in the correct order. Make sure to put the y first because we're trying to match the first equation. Okay, double check everything. 4, okay, I minus the 10, so it should be negative 10, and then 2x. Do I have them in the same order? Number, okay, equals, y thing, all right, and then x thing. Yes, all right. Double check because if they're not in the same order, then when you go to try to eliminate stuff, you're going to eliminate stuff wrong, and then you're going to get the wrong answer, and then it's terrible because especially if you make a mistake towards the beginning. That's why it's so important that you do this right, because this is the beginning of the problem. That's the worst time to make the mistake. At least if you make the mistake at the end and you catch it, you have less to fix to try to fix your mistake. But if you make the mistake at the beginning, that's a lot to correct. So make sure you're really getting that part correct. So all of these things can divide. I can divide all of these by 2. However, I noticed that if I times this equation by -2, I can get my y's to cancel. So I'm going to do that. So -14 equals -20y minus 7x. And then that's going to be -8 is equal to positive 20y. Make sure I get that negative in there. Positive 20y minus a 4x. And then that's going to be a negative 22. That's going to cancel there, and then that's going to be negative 11x. Divide by negative 11, negative 22, negative 11, that's going to be 2. Okay, and then I can plug it in, plug it in. Let's go ahead and divide everything by 2 now, because why not? So it's going to be 2, negative 5y plus x. Plug in my x, so negative 5y plus 2. Subtract 2 on both sides, so that's going to be y equals 0. And there we go. All right. We don't have a whole lot of space to do number 24, but we totally got this. We totally got this, guys. All right, here we go. It looks like we're also not in the correct order here. We want to match the second equation to the first. That's totally fine. You can have it just like that. Have everything on the left-hand side and set it equal to 0. Because why not? Why not? So negative 10x, negative 10x. Boom, boom. So I want the number first, okay? Then the x term, okay? Then the y term, okay? And then set it equal to 0. Cool. We have everything lined up. It does not matter what order everything's in, as long as they're both in the same order. All right? Would I recommend setting equal to 0? Maybe, maybe not. There's not really any issue with it. It might be like maybe there's like a scenario where it's one step slower than not setting everything equal to 0. So maybe don't do it that way, but I mean, you're going to get the answer either way, and you might be missing out on like one step. Okay, so it's not that big of a deal. Just line them up however you want, as long as they're lined up the same way. Okay, we do need either the x or the y to cancel. Right now, we can get the numbers to cancel, but we need the x or the y to cancel. So let's see, we can either times by 5 or 7. I'd rather times by 5. So I'm going to take this equation, times it by 5. So that's going to be 15 times that by 5, times that by 5, times that by 5. Still 0. Okay. Now the numbers are not going to cancel, but that's fine. I'm not trying to cancel the numbers. I'm trying to cancel one of the letters, or sometimes both. Okay, so then I get that. Subtract 12. Divide by negative 12. Y is 1. Okay, then I just plug it back in. 3 plus 2x minus y equals 0. So 3 minus 1 is 2. If I do that, so 2, and then I subtract 2 on both sides, I get that and then that. Aha, I did fit it. Haha. With some finagling. There it is. All right. Whew, that was it. Like I said, that's about as hard as I think it should get. I think the likelihood of you seeing questions that are harder than number 23 and 24 is extremely slim. Possible? Yes. Likely? No. This is about as hard as it gets. It can always get harder. I can think of problems that are at least twice this hard, but I don't think you're going to get problems that are twice this hard. I think that's highly unlikely. So hopefully that's encouraging that this is about as hard as it should get. Hopefully, probably, very likely. All right, and with that, we will close out the session. Hopefully that's been helpful, and I'll see y'all in another episode real soon. Have a blessed one.